Hello friends, welcome to our channel at Wolves, and today we are going to see how to find a voltage at a given node, okay, at a given point for a given circuit. Okay, this is a very typical problem and very important problem which is oftenly asked in your examination. Okay, uh, so let's begin. This is the circuit which is provided to us. Okay, you can see that this is our circuit, and in this circuit we are provided with one dependent source. Okay, which is that dependent source over here. Okay, so this is a dependent source. Okay, and why it is called a dependent source? Because the voltage, okay, this is a voltage source first of all. Hmm? And the voltage is controlled by the current I. Okay, the voltage is controlled by the current I, and that current I is flowing in this direction, which is shown to us. Okay, so we have to maintain that, we have to look at that this dependent source is not to be get disturbed until and unless you find the value of I. Okay, the next thing that we need to find the voltage at node 2. Okay, so this is the voltage, okay, at node 2. Okay, so please tell me that what amount of current is flowing between this 2 point, that is 15 volt and voltage 2. Okay, so the current, that is I, flowing between this 2 point is nothing but 15 minus V2 upon the total resistance of this branch, which is 50 ohms. This is the total amount of current flowing between this 2 point, that is 15 volt and voltage point 2. Hmm? I will take down this 50 to the another side of equal to, which becomes a 50 I equals to 15 minus V2. What I need to find is the value of V2. So V2 is equals to 15 minus 50 I. So this is the value of V2. Okay, V2, and you can see that if I only knew the value, or someone else tell me that the value of I is so and so, okay, for say 2 amperes or 3 amperes. Okay, so I will substitute that value, and simply by subtracting it from the 15 I can find the voltage value of V2 which they ask us to find. Okay, but as you see that we are not provided with the value of I, so our first job is to find the value of I. Okay, and let me tell you about that we are going to use a source transformation technique to solve this network, because you can also do with a mesh analysis, but you will find that it would become more and more complex rather than become simplified. Hence, the easiest method to solve this type of the problem is use a source transformation technique. Okay, so what I will do, I will transfer this voltage, dependent voltage, and the resistance are in series. Okay, so first of all look that they are in series. So what I can do, I can transfer this voltage source into a current equivalent current source. From Ohm's law, we have current equals to voltage upon resistance. So what is the value of voltage? That is 10I. And what is the value of resistance? That is 100 ohm. So my I becomes 0.1 I amperes. I forgot, but let me denote this current as I2, because it is flowing in branch 2, hence I denoted this current as I2. Okay, so this is my I2, not just I, because I is already notified with the some other current value. So this is my I2. Okay, so I just transform the voltage source into the equivalent current source of value 0.1 I ampere. So I also have to redraw the circuit. So this is my circuit. Afterward it will look like this. That is my 15 ohm, which is undisturbed. My resistance is undisturbed. Mm, Here my current source came into picture, and that is the value of 0.1 I amperes, and the resistance of 100 ohms gets separated from the branch, that is 100, and the last resistance, that is 100 ohm, is as it is. So this is my new circuit diagram will look like this. That is 50 ohms, 0.1 ampere current, 100 ohm, and this 100 ohm over here. This 100 ohm is this 100 ohm. Okay, so this is my circuit will look like. Now what I will do next, I will just combine these two resistance of equal resistance, probably the 100 ohm and the 100 ohm. Okay, to simplify my circuit further, I will combine the 100 ohm resistance. So saying that 100 ohm is parallel to 100 ohm, my equivalent resistance will become 50 ohm, because we know that when both the resistors are of same value, the resultant resistors become half. Okay, in parallel combination, only in parallel combination. So my circuit will look like this. My circuit will look like this. That is 15 ohm, and this is my resistance of 50 ohm. This is my current source and my equivalent resistance of 50 ohms, which I just found. This is my 0.1 I current source. This is my 15 ohm current source. So this is my circuit, which is this is my new circuit. Okay, after combining this two resistance value. Now again I will use a source transformation. Source transformation, and I will transfer this 0.1 I current source into a equivalent voltage source. So from Ohm's law I know that the voltage value is I into R. Okay, and this R is not just R, this is a 50 ohms R, that is equivalent resistance which we have just found. Okay, so V is equals to 0.1 I into R is 50 ohms. Okay, so the voltage becomes phi I. Okay, this is my new voltage of phi I. So my voltage will combine with a branch, and it will be in series with the equivalent resistance. So this is my old, that is 15 ohms volt voltage, and this is my resistance of 15 ohms, and here is let me draw somewhere else. Here is my V2 point. Okay, this is again is my 50 ohm equivalent resistance, and it is connected with a series uh, voltage source, dependent voltage source of phi I volt, and this finish my network. So you can see my current I is as it is. My voltage source, which I just transform, okay, is this. Now I can easily find the value of I in this circuit, okay, by using KVL. So by using KVL, so starting from the voltage source 15, so the voltage source 15 is equals to this 50 ohm plus this 50 ohm I into I, and the this value get subtracted because we are traveling in this direction, so the positive voltage is up and negative voltage is down, so minus phi I. So that will give me uh, let me correct this one. This is not minus, this is actually it is plus. Okay, yeah, that is not minus, that is plus. Okay, so that will give me 1 not phi I. Okay, and in resultant to this, my I value becomes 15 upon 1 not phi. So my I comes out to be 0.143 amperes. So this is my I value. So I found my I value. Now I will substitute that value in this equation over here. Let me call this equation as equation 1. So I will substitute the value in equation 1, which is V2 is equals to 15 minus 50I. So equation 1, V2 is equals to 15 minus 50. I value is 0.143. That will give me the value of V2, which comes out to be, if you calculate in your what we say, in your calci, so the 15 minus 50 into 0.143 gives me 7.85 volt. So the voltage at V2 is 7.85 volt. Thank you for listening.